Some of humanity's greatest inventions are impossible to ignore. Skyscrapers, airplanes, space rockets. But one of the most important inventions in history is almost invisible. Small enough to fit in the palm of your hand, yet powerful enough to shape the modern world. It exists inside your smartphone, your computer, your car, your television, your bank. Even the artificial intelligence transforming industries today depends upon it. This tiny piece of engineered silicon has become the foundation of the digital age. Without it, modern civilization would slow to a pace few people can imagine. It is called the semiconductor, and its story is far greater than a computer chip. For most of history, human progress depended on stronger materials: stone, bronze, iron, steel. Each defined an era. But the modern age was built upon something different, not stronger, smarter: silicon. A material found in ordinary sand, yet capable of controlling billions of electrical signals every second. Scientists discovered that by engineering silicon with extraordinary precision, it could become the foundation of modern electronics. That discovery did not simply improve computers, it changed the trajectory of civilization. Because once information could be processed at extraordinary speed, entirely new industries became possible. Inside every modern semiconductor exists an invisible city, not of buildings, but of transistors, tiny electronic switches, each one capable of making a simple decision: on or off. Alone, a single transistor accomplishes very little. Together, billions of them become something extraordinary. They calculate, store, communicate, predict, render graphics, train artificial intelligence, navigate spacecraft, secure financial transactions. Every second, modern processors perform billions, sometimes trillions, of operations. Not because one transistor is powerful, but because billions work together as one system. Once again, civilization advances through connection, not isolation. Making a semiconductor is one of humanity's greatest engineering achievements. Factories must remain cleaner than hospital operating rooms. Particles invisible to the human eye can destroy an entire chip. Machines align microscopic patterns with astonishing precision. Lasers shape structures measured in nanometers. Robots transport silicon wafers through hundreds of manufacturing steps. Months of engineering, thousands of specialists, and billions of dollars in equipment come together to produce a single generation of advanced chips. The semiconductor is not merely a product. It is the result of one of the most sophisticated industrial ecosystems ever created. Long before intelligence reaches a computer, precision must first reach perfection. Very few industries have the power to enable almost every other industry. Semiconductors are one of them. Artificial intelligence cannot exist without advanced chips. Cloud computing cannot process billions of requests without them. Modern hospitals depend on medical equipment driven by them. Airplanes rely on them. Power grids rely on them. Factories rely on them. Satellites rely on them. Financial markets rely on them. Even the device used to watch this video exists because of them. This is what makes semiconductors different. They are not simply another technology. They have become a universal foundation, an invisible layer supporting nearly every system that keeps modern civilization moving. For decades, semiconductors were viewed as a specialized industry. Today, they have become a strategic priority. Around the world, new fabrication plants are being built. Governments are investing billions. Technology companies are securing long-term supply. Universities are expanding engineering research. The objective is no longer simply producing more chips. It is securing the infrastructure that powers the digital economy. Because when a technology becomes essential to communication, healthcare, transportation, artificial intelligence, and national competitiveness, it is no longer just manufacturing. It becomes critical infrastructure. The race for semiconductors is ultimately a race to build the foundation of tomorrow's economy. For generations, progress in computing followed an extraordinary pattern. Engineers learned how to place more transistors into the same space, not by making computers larger, but by making components smaller. Each new generation delivered greater performance, lower energy consumption, and entirely new possibilities. Smaller chips enabled thinner laptops, smarter smartphones, faster cloud platforms, more capable artificial intelligence, and technologies once considered impossible. At first glance, a few nanometers may seem insignificant, but throughout history, some of civilization's greatest leaps have come from changes too small for the human eye to see. The future is not always built by making things bigger. Sometimes it is built by making them unimaginably smaller. A semiconductor is never created by one company or even one country. Behind every advanced chip exists one of the most sophisticated supply chains ever assembled. Raw materials travel across continents. Precision equipment is engineered with microscopic accuracy. Chemicals are manufactured to extraordinary purity. Specialized software designs billions of transistors. Factories produce silicon wafers. Advanced facilities package the finished chips. Global logistics deliver them to manufacturers around the world. Thousands of companies, across dozens of industries, contribute to a product smaller than a fingernail. This is the hidden architecture of modern manufacturing, a reminder that today's greatest technologies are rarely built alone. They are built through global collaboration, operating with remarkable precision. There was a time when semiconductor manufacturing was viewed as a specialized business. Today, it has become a strategic priority. Because advanced chips no longer power only computers, they influence artificial intelligence, healthcare, scientific research, transportation, energy systems, communications, and economic competitiveness. The question is no longer who builds the fastest computer. The question has become who can build the infrastructure that powers every intelligent machine. The semiconductor has evolved beyond a commercial product. It has become one of the strategic foundations of modern civilization, small enough to disappear inside a device, important enough to shape the future of nations. History remembers civilizations by the materials that defined them. The Stone Age, the Bronze Age, the Iron Age. Perhaps the modern world will be remembered for something far smaller: silicon. A material transformed into billions of intelligent circuits, quietly powering almost every digital experience, from the phone in your pocket to the artificial intelligence reshaping entire industries. The semiconductor is more than a technological achievement. It is proof that civilization advances not only through bigger inventions, but through greater precision. Because sometimes, the technologies with the greatest influence are the ones we rarely see. Tiny enough to fit inside our hands, powerful enough to transform the world. In the next episode, we explore another invisible foundation of the digital economy. Not the chips that process information, but the facilities that manufacture them. The semiconductor fabrication plant, where precision engineering pushes the limits of what humanity can build. NEXNET, the architecture of modern civilization.